State management, one of the most complex aspects of building single-page applications. In most cases, components need to communicate with each other by exchanging data. You can do this by passing props around, but this approach can easily get out of hand when a lot of data is involved. During the years, various approaches and patterns such as Flux were introduced to manage state and data exchange. While powerful, all these approaches come with a new API you need to learn and add yet another level of complexity into your codebase. As an alternative, React offers the Context API, which provides a way to share values between components without having to explicitly pass a prop through every level of the tree. In this video, we'll discuss the Context API use cases and touch on some of the best practices you need to keep in mind when working with application data. As a quick FYI, this video is part of a React crash course. Be sure to check the description for more videos in this series. Let's take a look at an example and understand what the Context API can actually help us with. I created an app component which has two state values: a logged boolean, which keeps track of the authenticated state of an user, and a theme value based on which we can easily change the appearance of the UI. When the login value changes, some more content is displayed on the page. Of course, this is a demo, but this is the type of use cases you'll run into in real life as well. Keep in mind that, as a best practice, you should avoid putting in the context data that changes too often. In theory, things like the theme preferences or the authentication status will change maybe once while using the app. These values will be needed further down in the component tree, since various components will need to know if they should render or not authenticated data, for instance. This is why we are passing all this information as properties to components such as the aside or the app header component. If one of the child components needs to perform an update on the logged or the theme values, it also needs access to the setter function as a prop. You can see that this can easily get out of hand, and we could end up with a lot of boilerplate code to perform the easiest tasks. For instance, taking a look at the app header component, you'll see that the props are passed down to yet another child component. Furthermore, since we are using TypeScript, I want to enable type support for the component properties, so these have to be declared here and again in the nested mainf component to follow best practices. There is a lot of redundancy, and this is why state management solutions and later the Context API were introduced. Let's refactor this code and get rid of all this prop drilling. If you didn't know by now, prop drilling is the practice of sending data at all levels of the component tree due to some requirements in the deeply nested child components. We'll start by defining a TypeScript interface for the context so that we can easily work with it in any part of our application. Next, we'll create a context instance using the React's createContext method. This method has type support, so we'll use the interface we defined earlier here. As a best practice, let's also create a default object to define defaults for each value in the context. Based on this minimal setup, we can now update the JSX and register the content provider for all child components. We are registering the logged and the theme state values in the provider so that we can easily change them via the setters if needed. Remember though that you should avoid changing context values too often, since each change will trigger a render in all components referencing the context. And now it's time for some cleanup. In the app header component, we'll get a reference of the context using the useContext hook. Since this object has the values we need, we can fully remove the props interface and the arguments the function was accepting. You can see the amount of code needed decreased quite a bit. Such approaches will help you a lot in the long run, since they really improve maintainability. We'll continue the refactoring with the mainf component, which is nested under the app header. Again, we can remove all the code related to properties. You can also use object destructuring to get the context values more easily. This approach should be clear now, so we'll not spend more time discussing it. All components can be refactored, and we'll end up with a much cleaner and concise code base. There is a fine balance you need to find between passing props and relying on the context. Keep in mind that besides the rendering applications, components that rely on the context are harder to be reused in other projects. In the React docs, you'll also find mentions about component composition as an alternative to relying on the context when avoiding prop drilling. In my experience, this approach is fairly cumbersome and difficult to maintain over time. Therefore, if you are in a situation where a lot of data really needs to be passed around in the component tree, a state management library will be the best solution for you. We'll discuss state management solutions in one of the next videos. Thank you for watching.